Hello everyone, this is Proshun sir, introducing myself as Physics and Chemistry faculty of Vidyadeep Science Tutorial. Please follow the contact number in the screen for any kind of support like lectures, notes, etc. and other guidance. Hi winners, this is P.K. Ghoshal, the teacher. I am here to derive today the Newton's kinematic equations of motion by calculus method. These equations can be derived by graphical method, by algebraic method and also by calculus method, and all the three methods are there in the syllabus of class 11. So we are just starting with it. So first equation is V equal to U plus AT. Second, S equal to UT plus half AT square. V square minus U square equal to 2S. This is the third relation. Now there are two more equations which can only be derived by using algebra. So we are not discussing it here. In the next video when I discuss the things by using algebra, I come to it. So starting with the case. Now acceleration of a body may be defined as the rate of change of velocity per unit time or with respect to that of time. Now we frame the equation like this: dv equals a dt. Now you try to integrate this. We integrate this like this, putting initial velocity as the lower limit, final velocity as upper limit, here from 0 to t. So naturally we get v minus u equals at. So v equals to u plus at. So we have already derived the first equation of motion as proposed to us by Newton. Now coming to the second equation. Now whenever we come to the second equation, we consider velocity. You can also call this velocity time equation. Now second equation, v means ds dt, the rate of change of displacement with respect to time. This is the way we write, and here it is the rate of change of velocity with respect to time. Now what we do, we just frame the differential equation in the same style: ds equal to v dt. Now you put this equation here. ds gives you u plus at dt. You solve it. ds gives you u dt plus at dt. Again you integrate this from a displacement s1 to s2, here from 0 to t, and here a is constant, so from 0 to t. We get s2 minus s1. This is equal to ut plus half at square. Now how we are getting it, I am just showing it here. Integration of dx gives you x plus c, you see. So integration of dt will give you t. Now when you integrate like this with the limits, it becomes like this, and you get corresponding t minus 0 t. Here again the same thing. Now here the things will change. Now this rule is that x to the power n dx, this gives you x to the power n plus 1 by n plus 1 plus an arbitrary constant c. Now when you put the limits, now again if you take x square you are taking, or where you take x, which is there in the theorem. So x dx gives you x1 plus 1 by 1 plus 1 plus c. That means x square by 2 plus c. Now when you try to solve it with the limits, you take u and v. So naturally when we go for the case here, or you take 0 and t, so t dt, so naturally you get t square by 2. The same thing you have attained here, and you got the second equation as furnished by Newton. So these are just the rough part to show you the mathematical story which is going behind the relationship. Now we come for the third relation. Coming for the third relation. Again, you need to consider acceleration. Now here, we take the same relation of acceleration. Now A gives you dv dt. Here we apply the chain rule. dv ds dt. I am writing the mathematical part here. dy dx you can write like dx dn, dy dn and dn dx. If these are nullified, you get dy dx. It is known as a chain rule. Now, this part is again the velocity, because the rate of change of displacement with respect to time is known as velocity. So, what we do, we just write it velocity here. So, A, this gives you v dv ds. Now, we will take the ds here and frame the corresponding equation. So, you get A ds v dv. Again, you integrate this from S1 to S2, from U to V. In the same way, we will integrate, and the same thing we will just land on. The same relations that come. Just to see how it is coming. A S2 minus S1. Here you get V square by 2. The same rule. U to V. You make it AS and you write V square by 2 minus U square by 2. AS you can write V square minus U square by 2, and 2AS gives you V square minus U square, or V square minus U square gives you 2AS. This is the third relation. Now here we can also write it like this. You make it S, so S equal to UT plus half AT square. So we can write it like this, no problem. Now what is S? S equal to S2 minus S1, the difference in the displacement. So this, by this way, we can solve the whole thing, or we can just get into the conclusion with respect to calculus. So we have solved we have simply deduced the various kinematic equations of motion with the help of calculus, and I hope it is very clear to everybody. So please comment, please just mention your views in the comments below, and also like, subscribe and share this video to all those people who needs it. And if you need any of my help or support, you can always get me in the WhatsApp number which is furnished below in the video. So I'm just ending up the video and hope it is clear to everybody. Jai Ma Bharati.